All right, so 2.3, finding domain and range. So y'all, they start out with two graphs on this one. So I'm going to put some points on this graph here, and we'll use these points to answer their questions. So let's see, they got a point at 0, 5. -1, 4. -2, 3. -3, 2. All right, let's see. Then I got -4, 3. So it sort of looks like a V shape here.
Where are you coming up with those numbers?
It's a picture they're giving us for this. So they're going to give you everything I'm writing right here.
Okay.
So this will be like y'all's number 1 in 2.3. They're going to give you a picture with looks like what, 7 points on it. And it's sort of shaped like a V on mine. So what they want us to do on this one for the graph, they want us to determine the following. And y'all, this has A, B, C, and D on it. So the first thing they want us to find on this graph is f of a -6. So y'all, here's what they're asking us on this. They're giving me a number on this function, remember? And when they put a number there, that's the number that would go in for the x. So they're basically, on this question, they want to know what y value has an x value of -6. Okay, so they're giving me the x, and I need to find what y value has that -6 as its coordinate, okay? So remember, this graph here is showing me the relationship between the x and y values. So we need to go find -6 on that x-axis and go straight up until we find our point. So y'all, here we go. -1, -2, -3, -4, -5. So here's -6 on the x-axis. So from -6, I'm going to go straight up and find that point. Now, for this point, we want to know, what is this y value? So y'all, let me look on my y-axis. So that's what? 1, 2, 3, 4, 5. So at the y value of 5 there. So that means f of -6 equals 5. So let me just play with y'all a little bit. So let's look at this point right here. This point is at -3. So that means f of -3 would equal what this y value is. And that would be what? 1, 2. Okay? So you find your point on the x-axis, go up to that point, and then you see what its value is on your y-axis, okay? Now, B, they want the domain. Now, MATLAB is going to give us our little parentheses to put our domain in. And y'all remember, the domain is the set of x values. So our domain is our x values. So I usually start left and go right with these x values. So here's my first point. If I come down, that has the x value of -6. The second point, if you come straight down, has the x value of -5. All right, my third point, if I come straight down, has an x value of -4. A fourth point, I come straight down, has an x value of -3. All right, y'all, what's my fifth point here? I come straight down, that has an x value of -2. And it looks like it's just going by 1 to the right on each of these, right? Here's my sixth point. I come straight down. That's at -1 on the x-axis. And y'all, my last point here is sitting right on the y-axis. So if you come down, if you're sitting on the y-axis, you have an x value of 0. So for all these points, this is the x values, right? 0 had that point, -1, -2, -3, -4, -5, -6, okay? And y'all, that's what you got to realize. I brought this graph paper today because I wanted y'all to realize that anything on this vertical line here, anything on that vertical line has the x value of -6. Then if you look at this point, anything on this horizontal line here has a y value of 4, okay? So you just got to think of graphs as a lot of vertical and horizontal lines on there, like a grid, okay? So y'all with me on the domain is the x values, okay? So now here's a tricky question. Find any x values for which f of x equals 3. So this question is the opposite of question A. On question A, they give me the x value and they wanted me to find the y value. Well, y'all here, they're giving us the y value and they want us to find the x, okay? So for that one, we're really looking for what x value has a y value of, what was that, 3? Well, y'all look at this. So since y is 3 on this one, I need to go find 3 on my y-axis. So here we go, 1, 2. So 3 is on this line right here, coming across. But y'all look at that. I got 2 different points on that line. Right, everything on this line has a y value of 3. So let's see what the 2 points are. So starting left, this first point, I go down and it has x value -4. And then y'all right here, remember, here's another point that's on that line for 3. This point also has a y value of 3. So when I come straight down, that has an x value of -2. So y'all notice the difference. Here, they gave me the x. We found our y value of 5. Here, they're basically giving you the y value of 3, and you're finding those x's. And since that's a V-shaped, there's 3 of these y values that would have 2 points on them, right? And then what's this? 2? 2 is the only y value that would only have 1 point. All right, y'all, let's see what they want D. D, they want the range. And they give you the little squiggly curves now. Now, y'all, let me show you how I do. When I do my domain, I went left to right. When I do my domain, I go from bottom up. Okay, so left to right on the domain, bottom up on the range. The range is the y values. Well, the smallest y value is going to be that point right there. So let's see. If we go to the y-axis, we see that that has a y value of 2. All right, going up the y-axis, these 2 points are next. These 2 points have a y value of 3. Now, when you're looking at the range, you don't have to put repeats in it. Although I had 2 points on 3 for the y value, I only had to list it once, okay? All right, so now next I'm going to these 2 points. These 2 points are next and have a y value of 3. Whoops, I done did that one, okay. Next 2 points are these 2 right here. And if you go over, they have a y value of 4. And then y'all finally, these last 2 points here, they share this y value, and that looks like a 5. So the domain is the x's. -6, -5, -4, -3, -2, -1, 0. The range is the y values 2, 3, 4, and 5. Okay. So y'all, guess what? The next problem is really similar to this, except on it, they're not going to use dots. They're going to use lines on it, okay? So let me get that one ready. All right, so y'all, it starts over here at 6. So 1, 2, 3, 4, 5, 6. All right, then let me see what it's doing. So it's all right, so I'm just trying to get me some points so I can actually draw this thing. All right, it goes that way, and then it is heading this way right here. All right, so let me pull that back up. I want to see that whole graph. So y'all, this is just a line. It's intersecting right here at 6 on the x-axis, and then it just sort of flows to the right. And it's going through this point right here, which is like 7, 1. And on this side, it's hanging out to the left, and it's going through this point right here that looks like 5, 1. So this would be like number 2 here. So for A, they want me to find f of 2. Well, remember, if I'm going to find f of 2, once again, what I'm looking for, what y value has an x value of 2. Now, let's see, what do y'all think? Here's my x value of 2 on my x-axis. So I need to go up and see where I'm intersecting that line at. So here's 2. I'm going up. It's intersecting my line about right here. So what I need to know is, what's that y value? Well, y'all, let's see. That would be 1, 2, 3. Looks like 4. The 4 is where it comes across and intersects that point. So that means f of 2 equals 4. Okay, so when they give you a graph, it's like instead of plugging the numbers in and getting the y values, you're plugging the x's in and looking for the y values, okay? So what was next? They wanted the domain. Now I want y'all to notice something. This arrow goes left, and this arrow goes right. That means this graph goes on forever to the left, and it goes on forever to the right. So my x's can be all these negative x's. It's also going to contain all these positive x's. So when you got a graph that goes in both directions, we say it's headed off towards negative infinity toward the negative side, and it's headed off towards positive infinity to the positive side. So to represent that, we call this all real numbers. Are y'all with me on that? Because notice these straight lines go forever to the left and it goes forever to the right. So there's no way we can sit and list all these numbers 0, 1, 2, 3 forever. So to sort of shorthand that, we just write all real numbers and we move on, okay?
And what was the difference between the first one? Because I mean, technically, it goes all.
Well, if you notice my first one here, I had dots. These were not lines that
Okay.
were going in both directions, see? To where this one here with the lines is covering every point, even these fractions in between and everything, okay? All righty, y'all. See, they want to know any x values for which f of x equals 1. So remember what I'm looking for now? I'm looking for x's. They're giving me the y value of 1. I'm looking for the x's. So do y'all, what do y'all think?
Would be 5.
So let's see, 1, 2, 3. Look at 5, because if you go on 5 and up, you hit 1 on the y-axis. So good job. 5 is one of them. What's my second one? Because here's one on
Seven.
in anything. Oh, what was it? I heard it. I think y'all said
7.
7, it sounded like, right?
Yeah.
And y'all, that's all you're doing here. Find 1, go across. And once again, that had 2 on it, okay? So how about my range? Now look here, here's your graph. Both ends are going upwards, heading towards positive infinity that way, headed towards positive infinity that way. So you can't use all real numbers on this one because the range is never in the negative values, is it? We never have any negative y values down here. Our range is always positive up here. So when you got something like that, we say that our range is the y values. And I'm going to show you sort of what stuff means here. So this tells you the variable. Y'all, this little line means such that. So we're saying the range is the y values such that. Well, y'all, what do we know about these y values? What's the smallest y value we have here?
0.
0. So that means our range is going to be y such that y is greater than or equal to 0. And then we close our parentheses. Okay, so we couldn't be less than because y'all, we didn't have no graph going down in this negative y values down here, okay? And y'all want y'all to realize the x's were all real numbers because those things shot to the negative x's over here and it's off into positive x's. So the x's covered everything. It's just the y values that were only positive, okay?
So say that that was down at -1 instead of 0.
So say my graph was down like this.
Uh-huh.
Uh-huh.
At that point, it's your
Greater than or equal to
okay.
-1.
All right.
Okay. For this one to be all real numbers on a graph like that, you would have to have, say, a part up here, and then maybe a part shooting down toward the negative side.
Okay.
But good job. Yeah, that would be like -1 and above, and so on. Okay. All right. So they give you two of those problems just to get you warmed up on that domain and range lingo. Okay. So what we're actually worried about is finding the domain of a function. Because y'all college algebra is all about functions in this class, okay? So to find the domain of a function. So when finding the domain of a function, the domain must include all x values that produce a real number when substituted into the function. So y'all, that means if they give me f of x equals blah, 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 my domain can only include the x's that when I put it into that function, I get a real number out of it. Now, real numbers can be fractions, negative numbers, positive numbers, zeros, all that fun stuff, okay? Now, um, there's only one thing we're concerned with at this point that would be considered not a real number, okay? Are y'all familiar with fractions? So let me just play with y'all on the side here. So we'll recall this info. Well, if you're given a fraction, something like a over b, what can that be not equal? There's one number that b cannot equal for this to be a real number. And that would be 0, right? Y'all, if y'all try to take a fraction and put a number over a 0, and you punch that on that calculator, it's going to give you an error. And it'll say error because you're dividing by 0. This kind of stuff, if b is equal to 0, you're going to get what we call undefined, right? And you cannot graph anything that's undefined. So anything like this, a over 0, we say that that is undefined. Y'all, you can't have a piece of cake if you have 0 cakes to start with, can you? Remember, that's what fractions are. How many parts of the whole do I have? Well, I can't have any parts if I don't have any cake, okay? So just remember, we cannot divide by 0 in math. So since dividing by 0 makes it undefined, so where would you graph something that was, say I had a 5 for my x, where would you plot 5 undefined at? You just can't do it, can you? So that's why we need real number outputs, because when we're graphing, we got to find our x's and our y's and all that fun stuff. So what this means is we must exclude any numbers from the domain that create a zero in the bottom of a fraction. Now, for any functions that do not contain a fraction with a variable in the denominator, so what I'm saying is, if you got a function and at this point, if it don't have a fraction with a variable in the denominator, then the domain is all real numbers. Okay.
Can you write out an example of what you're saying?
Oh yeah. Oh yeah. Now, here's the thing. If you do have a fraction, so if you got a fraction, you got to do a few steps. You're going to set the denominator equal to 0. Because y'all remember, the denominator is the only thing that can't be 0. So we don't care about the top of the fraction. We're only worried about any numbers that'll make that bottom equal 0. So we're going to set the denominator equal to 0. We're going to solve for the variable. And then finally, we're going to exclude any of those solutions from the domain. Okay, so let me play with y'all a little bit before we do their exercises, just to get y'all an idea of this. So y'all, suppose I'm given a function, and my function is f of x equals, oh, let me see what I want here. How about I get a 17 over x plus 3. So I want y'all to see one where I got a fraction actually here. Now y'all realize there's one number that I can put in for this x and make this equal 0 in the bottom, right?
-3.
-3. Because -3 plus 3 is 0. 17 divided by 0, undefined. So we can't plot that -3 value because the y value was undefined. So fraction, that's why I'm worried about it, right? So what I'm going to do, technically what you're doing when you solve that, you're just basically taking that bottom, setting it equal to 0, and now solve it for the x. Well, you ought to solve that for the x. Since that 3 is being added, we're going to subtract it from both sides. And look at that. There's that -3 you gave me, right? So for these ones, my domain would be x such that, so remember that means such that. Well, what do we know about it? X got to be a real number. because we said we wanted it to produce a real number. So x is a real number, and x cannot equal what?
0. Well, -3.
-3. So this is how we pretty much, this is almost the same as all real numbers, except we're now excluding that one -3. Y'all, -3 is the only number we can put in here to make that a 0 and make it undefined. Okay.
So we're trying to make it undefined?
Well, yeah, because we want to find numbers we got to exclude from the domain. We're only doing that so that we can kick that -3 out of our domain. Okay. Because if you put a 0 in here, well, 0 plus 3 is 3. You can divide that. You put a 4 in here, that gives you 7. 17 divided by 7, you can do that. You put negative numbers in here, -5, that'd give you 7 over -2. You can do that. What you can't do is put a -3 into that, because -3 plus 3 is 0, and 17 cannot divide by 0, okay? But y'all, any other number from -infinity to +infinity, I can throw into that, and it'll give me some kind of number back, okay? All right, so let me play off another one before I hit their examples. How about this? F of x equals, oh, what I want. How about x plus 7 over, oh, y'all, how about 8 minus x? Now, I wanted to do one with a variable on top and bottom. Because this variable on top, I don't care what it is. It can be anything on top. That x can even be -7 if it wants to be. Because -7 plus 7 gives me a 0 on top. And 0 will divide by numbers. What I can't do is have a 0 in the bottom. So to find out what numbers will do that, I'm just going to set 8 minus x equal to 0. And y'all, I want y'all to realize we're only concerned about that denominator when we're looking at a domain, okay? So y'all, we can solve that two ways. What would y'all do? Subtract 8?
Mm-hmm.
Okay. So that's going to leave a -x equals 0 minus 8 is -8. So y'all, what would y'all do to make that a positive x? Do y'all remember? You would treat that like a -1 on that, right? So remember, if there's not a number in front of the variables, you got to treat them like a 1. So if you see a negative in front, we treat that like a -1. Because we want that x positive when we're done. So that tells me that x is 8. If I put an 8 in here, 8 minus 8 is 0. And no matter what's on top, you divide by 0, that's going to make that undefined. So for this one, our domain would be x such that x is a real number and x cannot equal, what do we get, an 8? Oh, y'all, so watch this one. This one might fix y'all. F of x equals 2x minus 5. So let me ask you, can you do anything to make that undefined? Well, you can't make this undefined, can you? Because guess what? There ain't even no fractions here, right? So y'all remember what I said over here? For any functions that do not contain a fraction with a variable in the denominator, then the domain is
All real numbers.
all real numbers. For y'all, I don't see a fraction. So there's no way I can put any number in the world that you give me in for that x, you can multiply that by 2 and subtract 5 from it. There's nothing going to make it undefined like this problem. So since there's no fractions, x such that x is a real number. So y'all, what you got to get in your minds at this point is when we're looking at the domain of a function, the only thing I'm concerned with is a fraction. Okay?
The example you did right above, was it just a fluke that this worked out that way? Because when I'm looking at it, when we're wanting it to be 0 on the bottom, 8 minus 8 is 0. So instead of going through and subtracting your
Yeah,
x,
no, 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 no. I'm just showing you technically what you got to do, but yeah, you can look at that and say, hey, it's an 8.
okay. So
Yeah.
that's not a fluke that it turned out that way. That's
No, no,
okay.
no, 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 no. This is officially how you can say it was the 8 when you actually solve it and get that
Okay.
8 and stuff. But no, that's the only thing. When you set it equal to 0, you can tell, hey, you know,
Okay. I
that's
just
the
wanted to
only thing.
make sure I wasn't over
And
and
y'all sort of did that while ago when I had that 3 there, remember?
yeah.
Looking at it, hey, -3. Now, I'm not going to lie. Later on in life, when y'all learn how to factor and stuff, we're going to throw some of those x squared looking things underneath. So those are harder to just look at and say, hey, I need a 5 and a 3 or something. So yeah. In the beginning, you'll be able to knock that out pretty quick just looking at them and okay, that's what I need. All right, so these are going to be their examples. And all of these are going to say find the domain of the function. So for number 3, they got f of x equals 10 over x plus 15. Well, guess what? You got a fraction. And you can pretty much look at that and tell me, couldn't you, Aaron?
-15.
-15, so officially I'll just set it equal to 0 and subtract that 15. And x was -15. So you have to kick out that -15 you gave me. So let's say x such that x is a real number and x cannot equal what we get, -15. Okay. Now this one they give y'all A, B, C, D answers in this section, so it's pretty much multiple choice on these questions. Okay. All right, y'all. Number 4. Look here. We got P of x equals 2x minus 10. So
That
what's
a
my
P?
domain?
It's all real numbers.
All real numbers. Good job. No fractions there, y'all. So x such that x is a real number. And I think they just want y'all to really realize that you got to worry about fractions when we're looking at these domains, okay? All right, I'm going to turn the heat up a little bit. P of x equals, oh, y'all look at this, x squared plus 7. So I'm throwing the quadratics at you now.
All real numbers.
Good, because there's no fraction. X such that x is a real number. All right, y'all. So let's continue on. There's only 8 problems in this section. So it's not real bad. Let's see. This one will be like number 6 here. All right, this one has a g of x equals 4 over 4 minus 3x. So that's a little trickier because they threw that number in front of that x on us. But I do have a fraction, so I got to set the bottom equal to 0. So what would y'all do to solve that? Move the 4 first? So we could what? Move that 4 by subtracting 4. All right, the 4's cancel. I get negative 3x equals negative 4. And then we'll divide both sides by that negative 3. So y'all, that's going to cancel, give me my 1x. On these two negatives, we're going to make that a positive. And then I can't do nothing with that. 4/3. So the only number I got to kick out is the 4/3. So we'll have x such that x is a real number. And x cannot equal 4/3. All right, y'all watch this one. See what y'all do here. Oh, they're going to break out the absolute value. How about the absolute value of x minus 2?
All real numbers.
Man, there you go. X such that x is a real number. So you know these homework problems, there's only one or two where you actually got fractions, so the rest you're just going to click real number, and move on through, right? Well, we think about that, and then I'm going to break out a cubic on you then. How about an x cubed minus 5?
Still all real numbers.
All real numbers. X such that x is a real number.
Ladies, if y'all need me to hush, just tell me. I talk to myself and I forget that I'm on.
Oh no, I'm
You're
cool.
good.
I'm cool with that. But y'all, that's what 2.3 deals with. A couple graphs in the beginning, just getting you used to the domain and range, and then they break out the how to find a function domain, okay? All righty, so now how many of y'all was in foundation math or transitional algebra before this class?
I just got done with transitional.
Okay. So is this first math class for you, Aaron and Hildegard? Is this your first math in a while?
Since 2008.
Okay, so well, we got to bring back memories from. Hopefully, y'all remember a little bit about foiling and multiplying and adding like terms and all that fun stuff. So y'all, 2.4 deals with the algebra of functions. So if you're a little weak on foiling and all that, you won't be after today. How about that? There's 4 operations I can do with functions. I can do f plus g of x. So f plus g of x is basically my f of x function plus my g of x.
I got confused.
Okay, so when they give you this lingo here, f plus g of x, they just basically want you to add your 2 functions. So next we got subtraction, f minus g of x. Well, y'all, that's just going to be f of x minus or g of x. Now, I will say between these two, subtraction is trickier because you always put your functions in parentheses when you start. And you got to get used to distributing those subtractions. So when we hit one of those, I'll show you what's going on with that, okay? Third, we got multiplication. F times g of x equals your f of x times your g of x. So here's where you might be doing the distributive property, foiling, and all that fun stuff is on that multiplying, okay? Now listen here on this adding and subtracting. When we do the adding and subtracting, all we can do to those is add like terms. When you add like terms, you cannot change the variables, okay? When you're multiplying, if you got an x times an x, you can change those variables and make that an x squared, right? X times x is x squared and so on. So when you're multiplying is the time you can change exponents or when you're dividing. So this one will be f divided by g of x. That's going to equal my f of x divided by my g of x. But y'all, what can g of x not equal?
0.
0. So remember that g of x on fractions cannot equal 0, okay? So now that y'all know about fractional domains, y'all have always got to remember that about the 0, okay? So y'all, that's the thing. So let me just say right here, adding and subtracting basically means combining like terms, basically. And then subtraction, you could combine like terms after distributing the subtraction. Okay. Like I said, on the multiplying, we'll either use the distributive property, FOIL, or something like that. Just remember when you multiply variables, recall x to the a times x to the b equals x to the a plus b. Multiplying variables, I add those exponents, okay? And then really on dividing, you got to recall one thing. X to the A over X to the B equals X to the A minus B. So when you multiply, you add exponents. When you divide, you subtract exponents, okay?
Yeah, sure.
All right, y'all. So you got 4 operations we're going to be playing with. So number 1, given f of x equals x squared plus 1, g of x equals x minus 2. They want me to find f plus g of x. All right, y'all, so I'll do this one and then we'll knock out our little break. So we're finding f plus g of x. So f plus g of x is going to equal my f function plus my g function. So y'all, my first step when I do these, I start them out with parentheses. And then I'm going to put my f of x here and my g of x here. Because remember, we said f plus g of x equaled my f of x plus my g of x. So f of x was x squared plus 1. Well, they gave us g of x too. That was what x minus 2. Now, here's the thing. When your parentheses are behind positive things, we can drop the parentheses and everybody stays the same sign. So I'm going to drop these parentheses and bring out my x squared plus 1. I'm going to drop these parentheses and bring out my x minus 2.
If one.
Say again. Now, I dropped all the parentheses. Now, if this was subtraction, we would distribute it. That's what I meant up here on subtraction, okay? But adding, you can just drop parentheses. Everything stays the same sign as it was inside. Can you go further with this? Can you simplify that any further?
Yeah.
Yep, y'all, because y'all got like terms. So I'm just going to put mine in order. So the highest exponent would be my x squared. Then I would bring down my x.
Okay.
And then we got 1 minus 2. And I mean, what, a negative 1. So now I have no more like terms. I cannot go no further. And that's what MATLAB wants right there. Okay? So adding's not bad. Basically, you drop parentheses and you're just adding like terms on those, okay? All right, so we'll come back and do some multiplying and subtraction and all that fun stuff, okay? So, y'all, I'm showing 10:53. So how about we come back at 11:03? And I'll see y'all in a little bit.
Okay, there we go.
Alrighty, so for this number 2, y'all, we're given f of x equals x squared minus 4. G of x equals x minus 2. They want us to find f times g of x. So it looks like a little multiplication on this one. So f times g of x will equal my f times my g. So y'all, we put in x squared minus 4 for the f. And then my g would be the x minus 2. Just remember, parentheses right next to each other also implies multiplication on those, okay? So y'all, this is where we're going to FOIL. Y'all remember that, right? So the FOIL, you're just distributing things twice. So y'all, here we go. We're going to multiply x squared times the x. Now remember, this x don't have an exponent, so you're going to treat it like a 1 there. So the x2 times x gives me an x to the 3rd. Now, you're going to take this x squared and multiply by the negative 2. So that's going to give us a negative 2x squared. So all I did was distributed the x squared times both of these. Now we're going to distribute the negative 4 times both of these. So y'all, that negative 4 times that x gives us a negative 4x. And then we take that negative 4 times that negative 2. So that's what a negative times negative makes that what, a positive 8. Now notice, this one has no like terms on it. So I cannot add anything together because x3s don't add to x squareds. Neither one of those adds to x's, and none of those will add to the 8. So since I have no more like terms, that would be our final answer. All right, y'all, let's see what they're doing on number 3. They're giving me f of x equals x squared minus 4. G of x equals x minus 3. But y'all look at this. They want me to find g times g of x. So y'all look, they gave me f of x and I'm not even using f of x. They want g times g of x. So g times g of x will equal my g times my g. So g was x minus 3, so we're putting x minus 3 into both of these parentheses. And once again, we're going to FOIL that. So y'all want to take this first x, and I got x times x. So we're going to get an x squared on that. Then I'll take that x times that negative 3. I get a negative 3x. Now I'm going to multiply both of these by that negative 3 in the first parentheses. So I got a negative 3 times x, which is a negative 3x. And y'all finally, this negative 3 times this negative 3 gives me a positive 9.
9.
Now, can this one go further? And y'all, that would be definitely, because in the middle,
Negative 6x.
so I get an x squared minus 6x, and then bring down my plus 9. So when you FOIL, sometimes you don't have like terms, sometimes you do. If you do have like terms, you gotta combine those, okay? So y'all, that's a little bit of stuff they're going to hit us with. Watch out for what they're actually asking for. Do they want F times G or G times G, okay?
Do these come up as multiple choice in lab?
Most of these are. Well, the first 3 were. The first 3 were, but then they started getting into where you had to write the answers. Because watch this number 4 here. So watch what they're wanting on 4. So 4, they're giving us f of x equals negative 8x plus 11. G of x equals x squared plus 18. All right, so I got my 2 functions, but what they want me to find, they want me to find f of 7 plus g of 7. So y'all look, they're giving me numbers to put in for these x's now, okay? So here we go. We got f of 7 plus g of 7 equals my f plus my g. But y'all look here. I'm not putting negative 8x plus 11 here. Because y'all see what they did? They gave me a 7 for the f function. So what that means is I need to put a 7 in for that x. So that's going to give me negative 8 times 7 plus 11. Now, we're adding that to g of 7. So we're going to take the g equation, put a 7 in for that x. So I'm going to get a 7 squared plus 18. Now, at that point, you can throw it in your calculator. I'm probably just going to multiply them out real quick. So in the first parentheses, you got to multiply before you add. So negative 8 times 7 is a negative 56 plus my 11. In my second parentheses, I gotta do the exponent before I add. So 7 squared would be 7 times 7 is 49 plus my 18. So I'm down to my final step, so I can now get rid of my parentheses. So a negative 56 plus 11 is a negative, what's that?
45.
Negative 45. And then over here, 49 plus 18, I think that would be 67. Mm-hmm. And now my final step, add those together now. So 67 and a negative 45, that's a positive something. What are y'all getting? 22? 22, there you go. And y'all, that is our final answer. So they're not bad. If they give you numbers, you can just plug them numbers in and you're just following your order of operations down through there, okay?
This is gonna probably make you laugh, but is the order of operations, is that please excuse my dear Aunt Sally?
Uh-huh.
Okay.
So P is what?
Parentheses.
And really by parentheses, we mean work inside parentheses.
Okay.
E is all your exponents. And then the M and D are multiply and divide. So multiply and divide, you got to go left to right. And then finally the A and S, add and subtract. Add and subtract, also go left to right. That's why they say, please excuse my dear Aunt Sally from Little Rock. Little Rock lets you know you're going left to right.
Oh, okay.
Oh, y'all, let's see. Oh, this one has a negative 13x plus 14. G of x is x squared plus 7. They want us to find f of 10 minus g of 10. All right, so basically the same thing as number 4. They're still playing with the numbers. So my f of 10 minus g of 10 will equal my f minus my g. And they're giving me the numbers to put in. So it looks like both of them, they're wanting 10s put in. So this will be negative 13 times 10 plus 14. And the second one will be what? 10 squared plus 7. Okay, so I'm going to do like I did here and just work inside these parentheses for a second. So negative 13 times 10. So that's a negative 130 plus your 14. Over here, minus this parentheses, I'm going to square to 10. And that's going to give me what? 100 plus my 7. And y'all, I've still got one more step I'm going to do in between these before I do my subtraction. So let's see, a negative 130 and 14 is a negative something. Oh, maybe what? Negative 116? That's going to be minus the second parentheses. Well, that's what? 107?
Negative.
So that's a negative 116 minus 107 is a negative big number. A negative 2 something, y'all. What's that? Negative 2. 16 and 7 is what? 23. So we get a negative 223. So really on these, it's just keeping up with some signs. So those are a few with numbers. So let me see. I'm gonna skip down to 9 because 6, 7, and 8 were all similar to these. So I'm gonna skip down to 9. So these say for the functions, find the indicated sum, difference, product, or quotient. So for this one, they want me to find f minus g of x when f of x equals 9x minus 5 and g of x equals 3x minus 8. So notice they're not giving me a number this time. So when they don't give you numbers, you can't get a single number answer. You got to get some kind of simplified expression. So y'all, here we go. F minus g of x will equal my f minus my g. All right, f was 9x minus 5. G is 3x minus 8. Now, y'all, the most important part of this problem is what we're about to do. There's nothing in front of the first parentheses, so I can drop the first parentheses and come out with my 9x minus 5. But y'all notice, I now have subtraction instead of addition. So when you got subtraction, you got to distribute that negative to both of these inside the parentheses. So watch this. Here's a negative times a positive 3 makes that a minus 3x. So we're subtracting 3x. What's going to happen when you subtract a negative 8? I think y'all said it. What did y'all say?
8.
Because that's going to make that a positive, because now you're subtracting a negative, which makes that a positive 8. So subtraction changes the signs of everything. This 3x was positive, is now negative. This 8 was negative, is now positive. And y'all look at that. Can you go further?
Yes.
Yes, y'all. I got 2 sets of like terms. The x's are like terms.
Positive 6, 8.
So 6x. And then these numbers are like terms.
It's 3.
Because 8 minus 5 gives me a positive 3. And y'all, that would be our final answer. So that's the difference between these problems. Are they giving me numbers to put in for the x's? Or are they just wanting me to simplify these expressions, okay? So they're not too bad. The big thing in this kind of stuff is keeping up with some signs, okay? All right, y'all, let me see. I'm gonna do one like 10 because it's still doing subtraction. And to me, subtraction is tricky. So look here, f of x equals negative 4x plus 5. G of x equals x squared minus 5. They want us to find, now y'all pay attention, g minus f of x. So you see what they did to us? They reversed in that order on us. So let's come over here. G minus f of x will equal our g minus our f. Well, y'all, g's first, so that was x squared minus 5. And then that's minus my f, which is a negative 4x plus 5. So y'all know what we're about to do? We're about to drop these parentheses and bring stuff out. So the first part will be x squared minus 5. So the question is, what's the next 2 terms going to be?
Plus 4x.
Plus 4x. -5.
-5. Good job, y'all, because y'all distributing that negative through there. Good job. Oh, and y'all, we only got one thing we can do to that for like terms, and that's all those -5s, I guess. So bring down your x squared,
-10.
bring down your 4x,
-10.
and then minus my 10. Good job. All right, so 11 is just putting in a number doing that. So I'm going to skip to 12. Because 12 is tricky here. So y'all watch this one. F of x is going to equal x squared minus 3. G of x is going to equal 12 minus x. So I got my two functions, but y'all look what they want me to find on this one. They want me to find f times g of a little n. So let me get us started and then we'll see what we're going to put in these parentheses, okay? So we got f times g of n will equal our f times our g. But y'all, let me tell you this. I'm not putting the x squared minus 3 in here. What are we putting in here? Because what do they want me to throw in for that? They're putting it in here, right? So where you have an X, you now have to put an N. You got to plug in letters just like you would numbers on this, okay? So if they want to know what F times G of N is, then this F now becomes N squared minus 3. And guess what? This now becomes 12 minus N. So if a letter here is other than the variable in your function, then you gotta replace that variable with that letter. All right, 2 things times 2, so we're going to FOIL this. So y'all, I got an n squared times 12 is a 12n squared. I got an n squared times a -3. I mean a negative n. So n squared times negative n is a negative n to the third. So y'all, I did the n squared times 12, got 12n squared. I did the n squared times a negative n, got a negative n cubed. Now I do the -3 times 12. Well, -3 times 12 is a -36. And then -3, be careful on signs. -3 times a negative n.
+3n.
Positive 3n. And y'all, there's probably one more thing I would do to that. Because they want this in descending order. So you got to put the biggest exponent, then the next, and then the next, and then the number. So that n cubed is negative, so you got to keep that a negative n cubed plus my 12n squared plus my 3n and then minus my 36. So I just rearranged them and put them in descending order of exponents, but they still got to have their signs, okay? The n3 was negative and the 36 was negative, okay? So y'all just be aware of that. If you got f of x and g of x and they gave you an n here, you got to throw them in there, okay?
Oh.
Well, how about f of x equals x squared minus 2? G of x equals 14 minus x. So here's what we haven't done yet. They want us to find F divided by G of a 3. So really not too bad because they gave me a number on this. So I would come over here, F divided by G of 3 will equal my F on top over my G on the bottom. Now I'm not putting them in parentheses here because since I'm in fraction form, it's understood that they're in parentheses, okay? So on top is my F of 3. So instead of putting x squared minus 2, I'm going to put a 3 squared minus 2. There you go. And then on the bottom, G of 3 will be what? 14 minus
Minus
3.
3.
Hey, also, let's see, what is 3 squared?
Mhm. No.
So I get
7.
9 minus 2.
7.
And then there'll be 11 on the bottom. So y'all, I just got one more step on top. 9 minus 2, that's what gonna give me 7 over 11. At that point, can you reduce that?
Mm-mm.
Nope, so that would be our final answer. Hey y'all, that reminds me of an old store back in the day. Y'all might be too young, I don't know.
It's still around.
You get them Slurpees, remember?
You're still around.
Oh, are they?
Mhm.
Like what city?
In Little Rock.
Oh, really? Okay.
You have to go get you a Slurpee.
Well, I grew up off of Geyer Springs over that way
Mhm.
when I was younger. And there was always a 7-Eleven on 65th Street down there. So. And then you told them was another big one back then. I think that's what it was called. All right, y'all. So they're going to change the game up on us a little bit. So for these instructions, they say for the pair of functions f and g, determine the domain of the sum, difference, and product. So for these examples, we're looking at domains for the sum, the difference, and the product. So y'all, for this one, they're giving me f of x equals x squared. G of x equals 9x minus 9. So this is almost like 3 problems in one. We're going to find the sum domain, the differences domain, and the products domain. So let's start with the sum. Well, the sum means adding. So that would be f plus g of x. That's going to equal my f plus my g. Well, y'all, f is just x squared. G is 9x minus 9. Now, y'all, you can work this out and do all that fun stuff. But my big question is this. What's the domain of these two functions being added?
Ah,
They're all real numbers.
real number.
Because there's not a what?
Fraction.
There's no fractions here.
Much.
So since there's no fractions, there's nothing you can do to make that undefined. So good job. We got x such that x is a real number. So you didn't have to exclude nothing from this domain. But what about the difference? So the difference
Question.
is just going to be f minus g of x. So y'all, that'll be our f minus our g. So that's going to be the x squared minus 9x minus 9. So my question is, what is my domain of this being subtracted? Because guess what? I still don't see any
X is a real number.
x is a real number because there's no fractions on that. Because y'all, I can take any number in the world and square it. I can take any number in the world and multiply by 9 and then subtract 9. So there's nothing making that stuff undefined. Well, what about the product? F times g of x will equal my f times my g. So y'all, that'll be x squared times your 9x minus 9.
It would still be X is a real number.
A real
Yep,
number.
good. Yep, no fractions again, y'all, so good job. X such that x is a real number. And I'll tell you a trick on these. Adding, subtracting, and multiply pretty much always got the same domain. The one you got to watch for is division. But they didn't ask for division on this, and so we get to move on. So y'all, the same directions, but look here, what's going to happen. My f of x is now going to be 1 divided by x minus 5. My g of x is now going to be 6x to the third.
What's the word for division, like in, some
Quotient.
function? Okay.
So they might say find the quotient.
Quotient.
Uh-huh. So yeah, sum, difference, product, and quotient's the big ones for add, subtract, multiply, and divide, okay? All right, so first we're going to find the sum. Now, actually, my number 16 will be a little division, though. So the sum, that's going to be f plus g of x. That's going to equal my f plus my g. So that's 1 over x minus 5. And this is 6x to the third. So y'all want to take a shot at that domain? I can tell y'all what, it ain't going to be all real numbers this time, is it?
It's 5.
Because we got a fraction here, right?
Yep.
And y'all said that this couldn't equal, what'd y'all say, 5?
Yeah.
So this
Yeah.
cannot equal 5, because 5 makes that a 0. So you'll have x such that x is a real number, and x cannot equal
5.
or 5. There you go.
Yep.
All right, y'all, difference is next. But you're going to notice a little repetitious pattern here. So that's what f minus g of x equals my f minus my g. So y'all, that's 1 over x minus 5 minus my 6x to the third. And the domain is what? So x,
Same. X.
is what? Real.
And X. Different.
That's not equal.
There you go. So you noticing these ones are also looking like they're going to be all the same, don't they? So let's see about that product. F times G of X is my F times my G. And y'all, that's the same, right? 1 over X minus 5 times 6x to the third. You still have a fraction, so if that's a 0 down here, you can't multiply anything because it makes it undefined. So once again, I got the same domain, x such that x is a real number, and x cannot equal a +5. Okay, y'all, so I want y'all to realize adding, subtracting, and multiplying usually always got the same domains, okay? So if you can figure out one, you can get the other two, okay? Well, you know they want you to do a little dividing, right? So they say number 16 for division. So for the functions f and g, determine the domain of f divided by g. They're giving me f of x equals 7x minus 10. G of x equals 10x minus 30. So we're doing f divided by g, y'all. So f divided by g will equal my f on top, which is 7x minus 10, over my g, which is 10x minus 30. Now, you got a denominator here. So you can either figure out what number that can't be, or you can set it equal to 0 and get that number.
3.
So, and it looks like it's going to be, what'd y'all say?
3.
3. And when you solve it, you'll see that it'll give you 3 because you're going to add 30. And you'll get what? 10x equals 30. And then divide by 10. So that there you go, y'all. X is a 3. Notice, we didn't care about the top on this one, remember. All we were worried about was our denominator. So you would be x such that x is a real number. And x cannot equal or +3. Now, y'all, I'll tell you a trick. Since there's only one x down here, you only get one number you got to exclude. But later on, we're going to be dealing with x squareds. That gives you 2 numbers you got to exclude, okay? So the exponent usually tells you how many numbers you're kicking out of these domains.
Yeah.
So if I had an x cubed, I'd kick out 3 numbers, okay? All right, y'all, so that was 2.4 college algebra. So what I'm going to do is, this last little bit of time, I'm going to do your 2.4 support. So scattered throughout once in a while, you'll see in a support assignment, okay? And it's just to give you stuff to strengthen you for the college algebra. So y'all look at this one. They're giving me B plus parentheses 4B minus 77. And they just want us to simplify these by removing parentheses. Well, y'all, you see these parentheses are behind addition. So when they're behind addition, remember, we can just drop the parentheses and bring everything out. So this would really be a B plus a 4B minus 77. So y'all, one more step. Add my B's here. You got like terms. So remember, that's a 1 in front of this B. So 1 plus 4, give me what? 5B minus my 77. Now y'all notice, when I added these like terms, I don't change those B's. A lot of people, when they add, they make that 5B squared. Well, the only way to get a B squared is a B times a B, okay? So these are just getting you used to dropping those parentheses like those homework assignments in 2-4. So y'all try this one. 8D minus 3 minus parentheses 2 minus 5D. So the trick is what you're going to get out here. So the 8D and the minus 3, there's nothing happening to them at the moment. So I'm going to bring down the 8D minus 3. What I'm worried about, drop these second parentheses. What are y'all bringing out?
Minus 2 plus 5D.
Minus 2 plus 5D. There you go. So y'all, you got to distribute subtraction, okay? And oh, look at here. I got two sets of like terms. You can add the 8D and the 5D. So let's see, 13D. There you go.
Minus 5.
Plus
And
5.
then the, oh, what'd y'all say?
It'd be minus
Oh,
5.
minus 5.
Minus 5.
Sorry.
There you go.
Yeah.
Mhm. Remember, adding two negatives, keep them negative. So adding like signs stays with their like signs, okay?
Yeah.
Oh, y'all watch this one. They gonna pull that all parentheses on this one. A negative 8C minus parentheses negative 6D plus 6, those parentheses, plus parentheses 17C minus 8.
So
Let's see.
I'm gonna bring down that negative 8C.
Mm-hmm.
All right, what's next?
Negative C plus 6D.
So you got that one right there. So now
Mi-
distribute.
minus 6.
Uh-huh. All right, now keep me going.
Minus 6 plus
Uh-huh.
76. Minus
Keep
6.
going. Yep, there you go.
17.
And then there you go. So y'all doing good. You only distribute when they got the negative there. Good job. That'd be like a 1, and 1 ain't changing nothing, right? Oh, y'all, so let's see. Well, we got some C's we can add together.
Mm-hmm.
So negative 8 and 17.
Okay.
9C.
9 C. Yeah.
The D, there's only one 6D, so I'm just
Plus
bringing down my
6D.
6D.
16.
And then y'all got a negative 8 and a negative 8 being added. So that's a negative something.
Minus 4. Negative 14.
Minus 14. There you go. Hey, also, they started out working on the parentheses so that y'all could get used when you're subtracting those f of x's and g of x's. Number 4, they're going to practice you on your multiplying. Negative 4 times parentheses 7a plus 25. Now, here's the thing. When you distribute the sign and the number, just like you distribute these negatives up here. Well, now you're distributing a negative 4 times both of these. So negative 4 times 7a is what, a negative 28a?
28. Yeah.
And then how about that negative 4 times that 25? Negative
100.
100. There you go. And y'all, you can't do nothing else to that. So final answer. I'll tell you a little trick. If they're not like terms inside the parentheses, they won't be like terms outside the parentheses either, okay? All right, so I'm about to see what y'all play with on this one. How about this? We'll turn it up just a little bit. How about a 9m times n minus p plus q? Well, you're just distributing that 9m to everybody, right?
Mhm.
So 9m times n, can't do nothing with that. That's just a 9m n.
Okay.
Mhm.
Well, this is a positive times a negative, so that's going to be a negative 9m p.
Plus 9m cubed.
Plus 9m
M.
cubed. Let me show y'all a little thing about this. When you're doing this kind of work, this is called the distributive property. Now, later on, we'll learn if we start with this to get back to this, that's called factoring out a greatest common factor. So if you started with these three and went back to that, since they all had a 9m, that would be the greatest common factor, and then you write what's left in parentheses. So we'll sort of play with that later in life, going the other way, okay? Going this way, you're distributing. Going the other way, you're factoring out greatest common factor. All right, y'all, watch this. See what y'all get here. And I'll let y'all multiply this. 8c squared times 4c. So what's that going to give me?
32 C squared C.
Oh, you're so
No,
cool.
32 C
I
third.
think y'all saying a 3 there, right?
Yeah.
Because remember,
3.
you had a 1 here, and 2 plus 1 gave me
Yes.
3s, okay?
3. Uh-huh.
That's where they like to mess with y'all, not putting exponents on those variables that has 1 by them. So they sort of trick you up. All right, 3c times negative 2c cubed d3. Well, we know we can do the numbers first. So 3 times negative 2.
Negative 6.
Now, you got a c here. Well, the c can only multiply by the c to the third. So what's that giving me?
6 4.
Uh-huh. Because y'all remember there's 1 here, and 1 and 3 gave me 4 c's. And guess what I got to throw at the end of that? I got a D3 up here
3
still. So
CD. 3 CD 3.
and there you go. Well, you
Mhm.
multiplied the number, the C's, and then brought down the D. Okay.
Uh-huh. Uh-huh.
Now the reason I didn't distribute that, because all this stuff's being multiplied in here, okay? Y'all see the difference? Up here you had adding and subtracting, in between you distributed. Here, this is one thing times one big thing. So since they're not being added or subtracted, we just multiplied the 2 and the 3, the C's and the C's, and brought down the D, okay?
So if you
Mhm.
would have had negative 2c to the third plus d to the third, you would have the 3c
Uh-huh.
d.
I would have the negative 6c4 plus 3d3. Right? If there's a plus here, I'd have distributed that 3c to that d3 and got a 3c d3.
Okay.
Woo, keeping up with that alphabet there, huh?
Uh-huh.
All right, y'all. 4r plus 5t times 4r minus 5t. Now, y'all, I will tell you, when you got stuff that looks exactly the same like this, I don't know if they use this lingo in transitional, but these are called conjugate pairs. Conjugate pairs look the same other than the adding and subtracting. So watch what happens when you FOIL conjugate pairs. So I'll start with the 4r times 4r is a 16r
R square.
squared. There you go. Now do me the 4r times negative 5t. That's going to be a negative 20
Minus 20.
RT.
R.
And I'm just going to keep mine in alphabetical order as I'm going through, okay?
Yeah.
But y'all, what do we get here? 5t times 4r.
Positive
20.
20
Okay, and then finally, you got the 5t times a negative 5t.
Negative 25
minus
Uh-huh,
squared.
t squared, there you go. So here's the question of the day. What
T
happens to this stuff in the middle?
They cancel each other out.
They cancel each other
Negative.
out. And y'all conjugate pairs will always cancel out those middle terms, okay?
0.
So I get what, a 16r squared minus my 25t squared, okay? So y'all, that's why you'll do a lot of conjugate pair stuff later in life. Just remember, when you foil conjugate pairs, those middles will always cancel, okay? All righty. I think I've only got about 3 more of these to go through with y'all. But I like doing most of the support questions because those are the ones that help you get better for the actual college algebra class. Now y'all look at this. R minus F times R minus F. Now y'all guess what? These are not conjugate pairs because they're both subtracted, okay? Remember, to be conjugate pairs, one's got to be subtracted, one's got to be added. So this is just stuff we're going to FOIL, and stuff won't cancel on this one like it did on the conjugates. So y'all, we got an R times an R.
R squared.
All square.
R times a negative F is just a or negative FR. I just sort of keep mine in alphabetical order because if you get like terms, they're easier to look at. Now look here, a negative F times a R is another negative,
Negative.
and y'all watch this. A negative F times a negative F.
Negative F squared.
Oh, you're so close.
Oh, F squared.
Positive.
There you go. Positive F squared. There you go. Now, y'all, these don't cancel. That's a -1 and a -1. So that's going to basically make a -2FR. So I got my R squared
2F square.
minus 2FRs. And then at the end is our,
FR.
there you go. Okay.
Plus F square.
So if they're not conjugate pairs and they're the same factor being multiplied, you get the identical terms in the middle that you double. Okay.
Now, how come that wouldn't be negative FR squared?
This,
Uh-huh.
because when I'm adding, I can't change the exponents. So let me ask you this: if you're adding a nickel plus a nickel, would you get a quarter?
No.
So remember, when you're adding FRs and FRs, you still got FRs. You're just changing how many you got.
Okay, so it would be if they were being multiplied.
Yeah. Now, if I had a FR times a FR, then I would get F squared R squared. Okay.
Sorry.
Oh no, you're good. You're good. Those are the kind of questions y'all need to ask because
Thursday's a holiday.
and that's the main thing. You just got to remember. The only time I can change exponents is multiplying or dividing. When I'm adding and subtracting, all I can change is how many of things I got, okay?
No, this is some kids.
All right, y'all, x3 plus 7, x3 minus 6. So this is just two different things being multiplied, nothing about conjugates, or they don't even look the same. So how about this x3 times x3?
X to 9.
9. 9.
X to the,
Not.
are y'all
Nine.
saying 9?
Yeah.
Oh, y'all come back to Arkansas. 3 plus 3 is what?
Oh, 6.
Oh, 6.
Oh, okay. So remember, add exponents when multiplying the variable. That's probably why they did this one to y'all. All right, y'all. X3 times -6 is a -6. x to the third. And then you're going to do the inside. 7 times x to the third is a positive 7 x to the third. And y'all finally, I got what, a 7 times that negative 6. So that's what, a negative
And
42.
That's
Now you got like terms on that. So bring down your x to the 6. So we're negative 6 and a positive 7.
1.
It is
So
a 1.
X plus
So I can just do that, what is it, x to the third, there you go. And then minus
42.
my 42, okay? Now I think MATLAB will keep it if you do put ones there. If you did put a 1 in front of all these x's, it might take that. If it didn't, it would say, hey, you got the right answer, it's just not in the right form or something, okay? Now y'all, one more to go. C squared minus 4t squared times c squared minus 3t squared. So they're playing with the alphabet on this one just to see what y'all do to it. So y'all, let's walk through this one. A c squared times a c squared.
C
Oh,
to
hell, you can't get that wrong. Multiplying the more adding on that one, can you? Oh, me, 2 times 2 is 4, 2 plus 2 is 4. Okay, so we got a 4 no matter what on that one. All right, y'all, how about that? C squared times that negative 3t squared. So that's a negative 3. And then I'm just going to put mine in order. C squared, t squared.
Yeah.
So they couldn't change the actual letters because there wasn't but one c squared and one t squared, okay? All right, so let's do the inside. This negative 4t squared times c squared is a negative 4. C squared, t squared. Oh, y'all, finally. Let's see what y'all get here. A negative 4t squared times a negative 3t squared. So what y'all doing with that negative 4, negative 3?
Negative 4.
It would turn positive though, correct? Yeah.
Positive 12. And then how about that t squared, t squared?
Yeah.
Is a t to the...
4.
Well, hell, you can't miss that neither. Adding them or multiplying, I guess.
Sure. Yes.
And you know what's happening on this? Usually on these, you still already got like terms here in the middle. So I'm gonna bring down my C4. Y'all, how about this? Now, negative 3 plus a negative 4, and don't say positive.
Negative 7.
So negative 7. And then we still got what? C squared, T squareds. And then at the end would be my positive 12 T4. And then final answer. So y'all, this is what support does. It's giving you this kind of stuff so that when you got into the college algebra, you can do the foiling, you can do the multiplying, you can do the adding like terms and dropping the parentheses and all that fun stuff, okay? So y'all, that is 2.3, 2.4, and 2.4 support. So, questions on those? So y'all go activate them math labs if you haven't activated it yet. So when you go into Blackboard, go to the left side and click the MyLab student links. When you click the MyLab student links, it'll bring up the assignments, the grade book, and all that fun stuff. Click on your assignments because the very first one you got to do is that course agreement.
Mhm.
And the course agreement was just, I agree, I think, on everything, wasn't it? Yeah, so it's no math or nothing. You just agree to all the what financial aid stuff I think it was about and
Yeah.
stuff. So not really math related, but You gotta do that before you can actually access the first homework assignment, okay?
I got an email from you last night that said attend class.
Well, that
Was
wasn't
that
for
sent to
y'all.
everybody? Okay.
No, that was mainly for, y'all three have been here both times.
Yeah.
That's mainly for, we're up to 8 now. So today, one of them told me they couldn't come because they just got added. But I've got 3 or so that have been on the roster with y'all, and I haven't seen them yet, so.
I just wanted to make sure that I was showing up in your stuff that
Oh,
I was.
no, y'all are good, y'all are good, y'all are good. I've had, Aaron, I got you both days. Hildegard, I got you both days. Tricia, the one that logged off already, I've had her both days. And the only other one was our other person, Shaterica, yesterday, but she couldn't make it today, so. But other than her, we should have 1, 2, 4 other people. So, this class, if you went through the syllabus, you seen we have a 10% participation grade. Well, that's based off of these webinars. If y'all are attending, that's automatic, just coming to the Zoom, you're getting 10% of your grade automatically.
Yeah.
How could you give that up? I mean, I don't know, but if they don't come to Zooms, the highest they can get in my grade in my class overall would be a 90 because they're losing that 10%. So to keep it A, you'd have to make 100 on everything if you don't come to class. And well, that's a little tricky in this class,
Yeah.
so.
Another
Oh.
thing that I was just want to double check, I was going through the syllabus of the dates, and it's all by day. It has our first day starting on a Tuesday instead of Monday. Do I just need to shift everything up?
Oh, yeah, I think I forgot to do that. Summer 1, they was off the very first day, and then they started Tuesday. So,
Okay.
yeah, but we're still doing the same amount of work for week 1.
Okay.
Okay,
I'm just anal and I have to put everything in my
yeah,
calendar for what we're doing.
I
when we get
forgot
into
they was
school.
off Monday and we're off Thursday for this week. So I guess so remember.
Okay.
Mm-hmm.
All right. That's the only questions I had.
So anything else?
I don't think so.
So y'all go play with Math Lab, get that activated for sure. And I'll see y'all tomorrow at 10 o'clock.
All right. Thank you.
Okay.
All right, y'all have a good day.
Good day too. Bye.
All right, bye-bye.